Vertex form of a quadratic function is f of x equals a times the quantity x minus h squared plus k. It gives information about the graph without even drawing the graph. If a, the number in front of the squared term, if that is greater than 0, so if the coefficient of x squared is greater than 0, or if it's positive, then there is a minimum value. That means the parabola opens upward, there's a minimum value or a low point that it reaches, and that minimum value is the y-coordinate of the vertex. So for example, this f of x equals 2x squared plus 1. The 2 in front of the x squared, that is positive. That means the parabola opens upward. And if it opens upward, then there is a minimum value, and that minimum value is the y-coordinate of the vertex. Whenever you're talking about the value of a function, you're talking about the y value at a specific point. So there is a minimum value there. That minimum value is the y-coordinate of the vertex. Likewise, if a is less than 0, so if the number in front of the x squared is less than 0, or if it's negative, that means there is a maximum value. It means the parabola opens downward, and if it opens downward, there's a high point or a maximum value that parabola reaches. And again, whenever you're talking about the value of a function, you're talking about the y value at any particular point. So for that parabola, there is a maximum value, there is a high point that parabola reaches. So again, if the number in front of the squared term, if the coefficient of the squared term is positive, the parabola opens upward, and there is a minimum value. If the coefficient of the squared term is negative, the parabola opens downward, and there is a maximum value. Maximum value or the minimum value, either one, is the y-coordinate of the vertex. For y equals 3 times quantity x minus 4 squared minus 2, what are the vertex, the axis of symmetry, the maximum or minimum value, and also the domain and range? We're going to find those 4 things. Just a reminder, domain is a set of x values or the inputs. The range is a set of y values or the outputs. Also, vertex form for a quadratic function is f of x equals a times the quantity x minus h squared plus k. I'm going to start off by finding the vertex. Remember, in vertex form, h and k, those are the coordinates of the vertex. So in this 3 times the quantity x minus 4 squared minus 2, that's in the form of x minus h squared plus k. So the vertex is going to have coordinates of 4, 2. Now, if that was showing up as x plus 4, then the x coordinate of the vertex would be negative 4. But in this case, it's x minus h, x minus 4. The x coordinate of the vertex is positive 4. So the vertex is located at 4, negative 2. In the axis of symmetry, that's the vertical line that goes directly through the vertex. Remember, an axis of symmetry, a vertical line will start off as x equals, and then it's the x coordinate of the vertex. So the axis of symmetry there is simply x equals 4. It's the vertical line that goes directly through the vertex. The equation of that line is x equals 4. Maximum or minimum value, since that 3, the coefficient of the squared term, since that is positive, the parabola opens upward. And if the parabola opens upward, there is a low point or a minimum value that parabola reaches. Remember, the value of a function is the y value at any particular point. So since that parabola opens upward, the minimum value there is the y-coordinate of the vertex, and that is negative 2. As far as the domain and range go, it's good to see the graph to pick out the domain and range. As far as the domain is concerned, the domain is a set of x values. As this parabola goes higher and higher, it's going to extend out wider and wider. So as that goes up, it's going to extend clearer to the left, clearer to the right. So to negative infinity on the left and positive infinity on the right as far as the x values are concerned. So for the domain, the x values, you could say it's all real numbers. The domain is a set of all real numbers. All x values would be used in the construction of that graph. But the y values, that's a different story because the lowest y value is negative 2. So as far as the y values are concerned, you're starting with negative 2 and everything above that. So think about constructing this graph or making this graph. The y values would start at negative 2 but include anything above that. So you could state the range as all real numbers greater than or equal to negative 2. Now, some teachers or books may write that as y is greater than or equal to negative 2. That's fine as well. But think about the construction of the graph. The x values would include all real numbers, and the y values would include all real numbers greater than or equal to negative 2. For y equals negative 2 times the quantity x plus 1 squared plus 4, we're going to pick out again the vertex, the axis of symmetry, maximum or minimum, and also state the domain and range. Once again, domain is a set of x values, range is a set of y values, and vertex form for a quadratic function or quadratic equation is f of x equals a times x minus h squared plus k. H and k would be the coordinates of the vertex. So for this y equals negative 2 times x plus 1 squared plus 4, you can see since the coefficient of the squared term is negative, the parabola will open downward. So keep that in mind. As far as the vertex is concerned, when it's in vertex form, x minus h squared plus k, h and k would be the xy coordinates of the vertex, but here you have x plus 1 squared plus 4. Now to make that x plus 1, to stay in this vertex form, you would have to go x minus a negative 1. You can also think about the parent function. If you're adding 1 to the value of x, it's going to shift that parent function to the left 1 unit. So the x coordinate of the vertex, that's the tricky one there, that is negative 1. Again, to make an x plus 1, it'd have to be x minus a negative 1. Or think about moving the parent function. If you add 1 to the value of x, it shifts the graph to the left 1 unit, which would put the x coordinate of the vertex at negative 1. The y coordinate of the vertex, that's easy. It's just going to be what's showing there, and that is 4. So the vertex is located at negative 1, 4. The axis of symmetry, that's just the vertical line that goes directly through the vertex. A vertical line will start off as x equals, and then it's the x coordinate of the vertex. So that's pretty easy to do. Once you know the vertex, the axis of symmetry is just x equals, and then it's the x coordinate of the vertex. So x equals negative 1 is the axis of symmetry. As far as maximum or minimum, with that negative out in front, so the coefficient of the squared term is negative, that means the parabola opens downward. And if it opens downward, there'll be a maximum value. And that maximum value is the y coordinate of the vertex. So there is a maximum value here. It is the y coordinate of the vertex, and that is 4. And then for the domain and range, it helps to see the graph to think about the domain and range. As that parabola goes farther and farther down, it's going to extend out farther and farther to the left and right. So think about the x values that are used in the construction of this graph. As it goes farther down, it's going to get wider and wider. So all x values would be used in the construction of this graph. Or we could say the domain is all real numbers. But the y values, the range, that's a different story. Because the y values start at positive 4 and include anything below that. So you could say the range of the y values would be all real numbers less than or equal to 4. So domain is all real numbers, range is all real numbers less than or equal to 4 because that parabola opens downward. We're going to graph the function f of x equals negative 2 times the quantity x minus 1 squared plus 3. Now graphing on paper by hand isn't the most accurate way to graph a quadratic function. Whenever you're graphing a quadratic function, you probably want to reach for a graphing calculator if you have access to that. That's a more accurate, more efficient way to do it. But you do have to understand the process of graphing on paper or graphing by hand. And this is how it goes. First thing to note is that the coefficient of x squared is negative. So that means the parabola will open downward. Also, the x coordinate of the vertex, what we call h in vertex form, is 1. The x coordinate of the vertex is 1, and the y coordinate of the vertex, what we call k in vertex form, is 3. So that's the first thing to do is put the vertex down. That goes down at 1, 3. So go to the right 1 and up 3. Notice these units are all in units of 2 instead of 1, so it might look a little bit different. Once you get the vertex down, lightly sketch in the axis of symmetry. Remember, the axis of symmetry is the vertical line that goes directly through the vertex. So the equation of the axis of symmetry is x equals, and then it's the x coordinate of the vertex. So the axis of symmetry is x equals 1. Again, lightly sketch that in. That's not really part of the graph, but you have to know where that is. So x equals 1, it's a vertical line going through 1 on the x-axis. That is the axis of symmetry. And then from there, you want to either pick a couple points to the right or a couple points to the left of that axis of symmetry. Put those down, and then we'll match that up on the other side. So we're going to go on the right side here. We're going to put 2 in for x. So we're going to put 2 in for x and see what the value of y is. If you put 2 in for x, it'd be negative 2 times 2 minus 1 squared plus 3. That's negative 2 times 1 squared plus 3. It'd be negative 2 plus 3, and that is 1. So when x is 2, y is 1. That is 1 point on the parabola. You see another point up there a little bit sooner than it should be. That's putting 3 in for x. So if you put 3 in for x, again, that's a point to the right of the axis of symmetry. It's going to be negative 2 times 3 minus 1 squared plus 3. It'd be negative 2 times 2 squared plus 3. It's negative 2 times 4 plus 3, or negative 8 plus 3, which is negative 5. So when x is 3, y is negative 5. That's another point on that parabola. So there you have a couple points to the right. Remember, this axis of symmetry divides this parabola into 2 mirror images. Now here's the trick. You have to match those up on the left side. So I'm going to take that first point, 2, 1. Now your first thought might be the matching point is negative 2, 1. But if you put that point at negative 2, 1, it doesn't look like a U-shaped graph. It's a little bit off. So it's not negative 2, 1. Think about how far this is from the axis of symmetry. This point 2, 1 is 1 to the right of the axis of symmetry. So to get the matching point, you have to go 1 to the left of the axis of symmetry, which would put that at 0, 1. So 0, 1 is the matching point to that one. And then think about this point 3, negative 5. Now that point 3, negative 5 is 2 to the right of the axis of symmetry. So you have to go 2 to the left of the axis of symmetry. Remember, the axis of symmetry is where x equals 1. So if you go 2 to the left of that, the x-coordinate would be negative 1. The y-coordinate will stay the same, but the x-coordinate is negative 1. So that point would be negative 1, negative 5. So there are two matching points on the left side. Again, the more points you put down, the more accurate you'll be. It's not real easy to do on paper, not real accurate, but you get an idea of what it would look like. So then draw or sketch a U-shaped graph, or at least try to, a U-shaped graph through those points. And that would be somewhat what the parabola looked like. Not real accurate, but you get the idea. It's a parabola opening downward. The vertex is, again, at 1, 3. We've got a couple points to the right. Match those up with a couple points to the left. Sketch that in. That is the graph of that function. F of x equals negative 2 times the quantity x minus 1 squared plus 3. What steps transform the graph of y equals x squared to y equals negative 2 times x plus 1 squared plus 3? So each of these, the negative sign, the 2, the 1, the 3, they all do something to that parent function. The negative sign out in front, when you take the negative of the value of y, the value of y is this whole right side. Actually, x squared is the value of y. So when you take the negative of the value of y, that creates a reflection over the x-axis. So you're looking for one of these that has in it a reflection over or a reflection across the x-axis. Then that 2, when you multiply the y value by 2, the y value is that x squared. When you multiply the y value by 2, that creates a stretch. Stretches the graph away from the x-axis by a factor of 2. Then the plus 1, when you add 1 to the value of x, it's going to shift that parent function to the left 1 unit. When you subtract from the value of x, it shifts the graph to the right 1 unit. And finally, the plus 3, you're adding 3 on to the value of y. Again, the value of y is the whole right side. If you add 3 on to the value of y, it's going to shift the graph up 3 units. So you're looking for a reflection over the x-axis, stretched by 2, shifted to the left 1 unit, and also shifted up 3 units. And the one that matches that is letter D. What steps transform the graph of y equals x squared to y equals 2 times x plus 2 squared minus 5? So what does the 2 do? What does the 2 inside the parentheses do? And what does the negative 5 do? That 2 out in front, that again stretches the graph by a factor of 2. When you multiply the y value, that whole right side, by 2, it's going to stretch the graph away from the x-axis by a factor of 2. The 2 on the inside, when you add 2 to the value of x, when you add to the value of x, it's going to shift the graph to the left. So when you add 2 to the value of x, it's going to shift the graph and translate the graph to the left 2 units. And then finally, the minus 5, you're subtracting 5 from the value of y. The value of y is this whole right side. When you subtract 5 from the value of y, it's going to shift the graph down 5 units because you're subtracting 5 from every y value. So those are the transformations. Stretched by a factor of 2, translated 2 units to the left, and then also shifted or translated down 5 units. Which of the following best describes how to transform y equals x squared to the graph of y equals 4 times the quantity x minus 2.5 squared minus 3? So the big question is, what does the 4 do? What does the negative 2.5 do? And what does the negative 3 do? So when you multiply the y value by 4, you're taking that whole right side, the x squared, multiplying by 4, it's going to stretch the graph away from the x-axis by a factor of 4. Imagine taking every point on that parabola, multiplying the y value by 4. It's going to stretch that graph away from the x-axis by a factor of 4. When you subtract 2.5 from the value of x, so if you subtract from the value of x, it's going to shift the graph to the right 2.5 units. In this case, and also subtracting 3. When you subtract 3 from the value of y is that whole right side, or that x squared. When you subtract 3 from the value of y, it's going to shift the graph down 3 units. Imagine taking every point on that graph, subtracting 3 from every y value. It's going to shift the graph down 3 units. So you're looking for the one that says stretched by a factor of 4, shifted to the right 2.5 units, and shifted down 3 units. and that is letter C. What is the equation of the parabola with the vertex of negative 4, 6 and passing through the point negative 2, negative 2? Well, you put those down, get a look at them, see where they're at. The vertex is the top point, that's negative 4, 6, go to the left 4 and up 6. And the other point on the parabola is negative 2, go to the left 2 and down 2. So you can see that vertex is the top point, and another point on the parabola is below that. So if the vertex is the top point, another point on the parabola is below that, that means the parabola has to open downward. Keep that in mind. Also, the vertex is located at negative 4, 6. In vertex form, a times x minus h squared plus k. To have an x-coordinate of the vertex being negative 4, it would have to be x minus a negative 4. So inside the parentheses, x minus a negative 4, that would be x plus 4. So you're looking for an equation with x plus 4 inside the parentheses. And after the parentheses, since the y-coordinate of the vertex is 6, after the parentheses would be a plus 6. So you're looking for x plus 4 squared plus 6. You can throw letter F and G out because those don't match. Remember, this parabola opens downward because the vertex is the high point there, and the other point on the parabola is below that, so the parabola has to open downward, meaning the coefficient of the squared term would be negative. So with the coefficient of the squared term being negative, the vertex being at negative 4, 6, letter I would be the correct answer on that.